You might have worked with a lot of controllers till date. You might have worked with Raspberry Pi or Arduino's different versions. But before choosing the next microcontroller, these are the 5 different factors that you have to check before choosing your controller or upgrading yourself from a basic controller to the next one. So there are exactly 5 different factors in choosing the next controller or upgrading from a basic controller to the next one. So these 5 factors here are microcontroller, and the second one is programming interface, third one is how many number of input and output purpose pins that you have on your controller, and the last one is power, which is the most important section of all. So starting with the first microcontroller, which is also called as the heart of a complete microcontroller, the center or core MUSI or microcontroller unit that you have. What exactly it is? Is it an AVR based microcontroller, or which architecture it is reading with, AVR or ARM? So based on that, and the next important one is it an 8-bit microcontroller or a 32-bit microcontroller? So what exactly it means by 8 and 32-bit? If you have an 8-bit controller or a 32-bit, the number of addresses or the size of the address or the size of the integer key data types, what exactly, these all are dependent upon the microcontrollers, that 8-bit or 32-bit. So it's a very known number that you have to first look at. And the second important here is, are you trying to do some kind of a crazy stuff like synthesizing music, or are you trying to connect LEDs or big LEDs and run them on it? Even though this 8-bit and 32-bit can do it, there sometimes requires a high core processor inside the microcontroller which enables us to do this kind of stuff. So you need to just think about what exactly is the core purpose of choosing the next microcontroller, upgrading from the basic one to the next one. What exactly is the need of it? So once you understand or underline what exactly is your purpose, and the next thing to check is these factors of your core microcontroller unit of the next controller that you want to choose. And the next important one is programming interface. What exactly is the programming interface present on your microcontroller board? So what exactly it is? Sometimes if you take the case of Arduino's family, there are multiple secondary microcontroller units which enables you to program it via an USB cable which directly connects for your personal computer or your laptop or anything. So there is some kind of 16U2 or 8U2 depending upon Mega or Arduino Uno. There are secondary microcontrollers which can help you to convert the USB kind of communication to the kind of communication that your microcontroller can understand. So if you take one other variation of it, if you take Leonardo, Arduino Leonardo, then it doesn't require any kind of secondary microcontroller unit because it has a capability of accepting directly from USB. So depending upon what exactly is your programming interface that you are happy at. So are you an intermediate embedded engineer, or are you an semi advanced roboticist? What exactly are you at which level are you right now? So are you capable of directly using the ICSP pins on the microcontroller and use a dedicated programmer and dump the program that you have done in assembly or C language directly into the core microcontroller? Or you need a secondary microcontroller unit on the board so that you can directly dump it from USB. So what exactly, at what level are you and what exactly you are comfortable with? So based upon that, choose what exactly are the programmable interfaces present and then go along with that. The third important point here is general purpose input output pins. So this is a very most important factor before choosing the next microcontroller. What exactly it tells us? The number of GPIO pins. Are they 30, 14, 40? We don't know. Choose exactly based upon your requirement. We don't require 100 GPIO pins if you're doing for a small application with only 2 or 3 sensors on board. You don't require 40 or 45 pin GPIO pins unless and until you really use them, right? So based upon your requirement, number of GPIO pins that your application requires. So sort out this, what exactly you need to know. You need to know how many sensors are needed. What exactly are the number of signal wires coming from the sensors, or how many actuation processes going on from your controller. Do I really need 4 motors to be controlled or 2 motors to be controlled? Depending upon that, how many number of signal wires should my microcontroller should support with. And the most important one, if you are an intermediate embedded engineer or a roboticist, how many types of communication protocols does my microcontroller unit can support? For example, we cannot have any camera to work with I2C or SPI. They don't do generally. They can work only with USB or some other protocols which are not I2C and SPI. For example, to understand this, how many ADCs or how many I2C or how many communication protocols does it support? Just go through the data sheet of your microcontroller and then see how many of those pins are multiplexed to either PWM or common interrupts or some kind of programmable interrupts, or what exactly are the communication protocols, or how many pins are allotted to different protocols that I am interested in. So this is a very crucial step. This is very crucial step. So stay focused at this point whenever you're choosing your next microcontroller. And the last one is power. Of course, we need power for microcontrollers because they all are, they need a source to move, right? So here, when it comes to power, most of the microcontrollers will be available or will work in a range of 6 volts to 20 volts. Most of them. Then when it comes to the logic levels, earlier whenever I said like the general purpose input output pins, they have few logic levels to trigger or give pulse out or take pulse or anything. So what exactly are the logic levels they are working at? If you take a sample, for example, if you take Arduino Uno and Arduino Zero, Arduino Uno, some of the Arduino families or most of the Arduino families will work with either 5 volts logic levels. Logic levels here means a digital high will be considered as a 5 volts, a digital low is considered as a 0 volts. Similarly, Arduino Zero, one of the Arduino's family board, Arduino Zero, will only work with 3.3 volts as digital high and 0 volts as digital low. So what exactly is the digital logic or logic levels of your GPIO pins? Because if you know this, you can then easily use reference voltages whenever you're trying to map your analog waves on analog signals that you're getting from your sensors. So knowing about power is very crucial if you're working with multiple different kind of sensors on microcontroller. So these are what exactly are the 5 different factors that has to be your checklist before choosing your microcontroller. But along with that, it's very much important to also understand how many sensors are you going to connect, what exactly are the communication protocols that you need, and how much is your battery pack able to give, and what exactly is the voltage that you also require for your microcontroller.